Here we have a SAT math problem. Okay, let's go to the question. 8 times p negative 1 equals to 5 times p square negative 1 negative 6 times p negative 1. If p is greater than 1, what is the solution of the equation above? Solution of the given equation is the value of p, and we have to find the value of p such that p is greater than 1. Okay, now let me take the given equation as it is. That is 8 times p negative 1 equals to 5 times p square negative 1 negative 6 times p negative 1. Okay, here for this one, let me consider exponent 2. Even if I take exponent 2 for this one, it is still equal to 1. Okay, let me consider an algebraic identity. There is a difference of two squares, that is a square negative b square. Whenever we have an expression in this form, that is a difference of two squares, it can be written in factor form, that is a positive b times a negative b. When I consider the expression over here p square negative 1 square, it is exactly in this form a square negative b square. So now what we can do is we can write this expression in factor form like a positive b times a negative b. Okay, here when I compare this one and this one, at the place of a we have p and at the place of b we have 1. So when I write this one in factor form like a positive b times a negative b, here at the place of a I have to write p and at the place of b I have to write 1. Okay, now let me do it over here. 8 times p negative 1 equals to 5 times. Now we can write this one in factor form like this. Then I'm getting p positive 1 times p negative 1 negative 6 times p negative 1. Okay, now let me assign two new variables for p positive 1 and p negative 1. That is let a equals to p positive 1 and b equals to p negative 1. Now I can plug in this a for this p positive 1 over here and b for p negative 1 over here and here. Then I'm getting 8b equals to 5, and for this one we can plug in a, and for this one we can plug in b. Then we get 5ab negative 6, and for this one we can plug in b negative 6b. Okay, now let me subtract 8b from both sides of this equation. Then this positive 8b negative 8b will cancel out on the left side. I'm getting 0 here. 5ab, when I combine this negative 6b and negative 8b, I'm getting negative 14b. And the same equation can be written as 5ab negative 14b equals to 0. Okay, here when I consider the terms of this expression on the left side, I find b in common. So we can factor b out. When b is factored out, we are left with 5a in the first term and then negative 14 in the second term. Okay, equals to 0. Now I got the factor form of this expression over here. Now, the product of these two quantities equals to 0. Whenever the product of two quantities equals to 0, the first one has to be 0 or the second one has to be 0 or both of them may be 0. That is b equals to 0 or 5a negative 14 equals to 0. In this one, it is already solved for b, that is b equals to 0. Let's solve for a in this equation. Okay, let me add 14 to both sides of this equation. Then this negative 14 positive 14 will cancel out. I'm getting 5a equals to 14. Let me divide both sides of this equation by 5. Then this 5 will cancel out. I'm getting a equals to 14 over 5. Okay, here I have solved for a and b. Actually, we have taken this a and b to make the solving process easier. Now we can replace this a and b by the original stuff for p positive 1 and p negative 1. So that is, we can plug in this p negative 1 for b over here. Okay, let me do it. Then I'm getting p negative 1 equals to 0. Let me add 1 to both sides of this equation. That's negative 1 positive 1 will cancel out. I'm getting p equals to 1. And now let me plug in this p positive 1 for a over here. Then I'm getting p positive 1 equals to 14 over 5. Let me subtract 1 from both sides of this equation. This positive 1 negative 1 will cancel out. I'm getting p equals to 14 over 5 negative 1. Okay, here we do subtraction between a fraction and an integer. Whenever I want to do addition or subtraction between a fraction and an integer, I have to multiply this integer by the denominator of the fraction. Once I am done with this multiplication, I can take this 5 as a common denominator. Okay, let me do it over here. P equals to, let's multiply this integer 1 by 5. Then I'm getting 14 and negative 5. Now we can take this 5 as a common denominator. Then we get p equals to 14 negative 5 is 9. That is, we get 9 over 5. P equals to, when I divide this 9 by 5, I am getting 1.8. Here I got a value of p. Okay, here I got two values for p. One is p is equal to 1 and other one is p equals to 1.8. But the question says p has to be greater than 1. So this value over here for p does not meet the condition given here. So we can reject this one. And here we can consider this value 1.8 for p because 1.8 is greater than 1. Therefore, the value of p is 1.8.